Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zairi bin Jamaluddin. We from BMMA S2/1 Group 2, and today we are going to talk about refrigerator. What is refrigerator? Refrigerator are cyclic device, and the working fluid used in the refrigeration cycle are called refrigerant. A refrigerator is shown schematically in figure. QL is the magnitude of the heat removed from refrigerated space at temperature TL. QH is the magnitude of the heat rejected to the warm space at the temperature TH, and W net in is the net work input to the refrigerator. QL and QH represent magnitudes and thus are positive quantities. The performance of refrigerator is expressed in terms of coefficient of performance, COP, defined as COP refrigerator equal to desired output over required input, or equal to cooling effect over work input, or QL over work net in. The cooling capacity of refrigeration system is the rate of heat removed from the refrigerated space is often expressed in terms of tons of refrigeration.
Hi, my name is Hadi bin Asril. Today I will talk about the history of refrigerator. So, the earliest form of refrigeration was in the primitive times, which is 500 BC. That forms of refrigeration was called an ice house. These were commonly used to store ice throughout the year, usually cut from nearby lakes and rivers. In 1740s, the first form of artificial refrigeration was invented by William Cullen, a Scottish scientist. Cullen showed how the rapid reheating of liquid to a gas can result in cooling. This is the principle behind refrigeration that still remains today. Cullen never turned his theory into practice, but many were inspired to try to realize his idea. Next, in 1802, Thomas More, an American businessman, created an icebox to cool dairy products for transport. He called it a refrigerator until he patented refrigerator in 1803. Next, in 1834, American inventor Jacob Perkins, living in London at the time, built the world's first working vapor compression refrigeration system, using air in closed cycle. His prototype system worked and was the first step to modern refrigerators, but it didn't succeed commercially. Next, in 1840s, the first icebox were made by carpenters, designed to take advantage of the regular household delivery of large blocks of ice. They were insulated wooden boxes lined with tin or zinc and used to hold blocks of ice to keep the food cool. A drip pan collected the meltwater and had to be emptied daily. The popular use of ice refrigeration was coming to an end, as using natural ice posed health problems because of pollution and sewage dumping. The solution became ice mechanical manufacture, leading the way for electric fridge freezers. In 1876, German engineering professor Carl von Linde patented the process of liquefying gas that has become part of basic refrigeration technology. His findings led to his invention of the first reliable and efficient compressed ammonia refrigerator. Refrigeration rapidly displaced ice in food handling and was introduced into many industrial processes. Next, in 1913, the first electric refrigerator for domestic use was invented by American Fred W. Wolf and was called the DOME, or the Domestic Electric Refrigerator. In 1918, William C. Darren started the Frigidaire Company to mass-produce refrigerators based on Alfred Mellow's invention of a self-contained refrigerator with a compressor on the bottom of the cabinet. Next, 1927, General Electric introduced the monitor top, which became the first refrigerator to see widespread use. More than 1 million units were produced. Heat compressor assembly, which emit a great deal of heat, was placed above the cabinet. These refrigerators use either sulfur dioxide or methyl formate as a refrigerant. In 1940s, home freezers as separate compartment or larger than necessary just for ice cube were introduced as frozen food. Previously, a luxury item became commonplace. In 1945, full mass production of modern refrigerators began after World War II. The 1940s brought the bottom cooling refrigerator was the refrigerator we recognize today. It brought efficient food storage to the American home, setting a new standard of food safety. In 1970s, focus turned to more energy-efficient refrigerators and elimination of chlorofluorocarbons in refrigeration seal systems. The environment became a top priority in the 1970s and 1980s when freon was seen to pose a threat to the ozone layer. Next, in the 1980s, the first energy labeling programs were launched in many countries around the world, allowing consumers to compare the energy efficiency of products such as refrigerator. Next, in 1990s to 2000s, companies started to apply the Internet of Things to home appliances. LG launched the world's first connected refrigerator, and Samsung released models of Wi-Fi and cameras that help keep track of when food is about to become spoiled. And next, 2000 and beyond, environmentally friendly design are on the rise once more. A Russian designer imagined a future fridge with the zero energy bio refrigerator concept using a cooling gel that suspends and cools food.
So how refrigerator works? Well, there are three ways how refrigeration system works. First of all is cascade refrigeration system. In some industry, the application of refrigerator require moderate low temperatures and the temperature range that they involve may be too large for a single vapor compression refrigeration cycle to be practical. When the required temperature are wide range, the pressure are also wide range in the cycle and poor performance for reciprocating compressor. To counteract this problem, we perform refrigeration process in stage, which means we use two or more refrigeration cycle that operates in series. This refrigeration cycle called cascade refrigeration system. The two cycles are connected through the heat exchanger in the middle that serves as evaporator for cycle A and condenser for cycle B. While assuming the exchanger itself is well insulated, also kinetic as well as potential energy are neglected, heat transfer from cycle B to cycle A should be equal. The second system is multi-stage compression refrigeration system. If the fluid that was used all the way in the cascade refrigeration system is the same, the heat exchanger between stages can be replaced by mixing chamber or flash chamber because it has better heat transfer efficiency. This system called multi-stage compression refrigeration system. In this particular system, the liquid refrigerant expand in the first expansion path to flash chamber pressure that is the same like compressor interstage pressure. Some of the liquid will vaporize in the process, and in this saturated vapor is mixed with the superheated vapor from the low pressure compressor, and then the mixture will enter the high pressure compressor. This is in other way a regeneration process. The saturated liquid will expand throughout second expansion valve into the evaporator where it will take the heat from the refrigerated space. The third system is multipurpose refrigeration system with a single compressor. In some cases, industry applications need the refrigerator to be more than one temperature. This requirement can be achieved when we use a separate throttling valve and a separate compressor for each evaporator operating at different temperature. But this kind of system will be big and non-economic friendly. More practical approach will have to reroute all the exit streams from evaporator to a single compressor, and it will handle all the compression process in the system. Most refrigerated goods will have high content of liquid, and the refrigerated space need to be above ice point to avoid freezing. The freezer part of, however, need to be maintained around negative 18 degrees Celsius. So the refrigerant need to enter the freezer at about negative 25 degrees Celsius to let the heat transfer at reasonable rate. If we use single valve and evaporator, the same negative 25 degrees Celsius refrigerant will circulate all the compartments in the refrigerator, causing ice formation nearing the evaporator coils and dehydration of the product. But this can be solved by throttling this refrigerant to a higher pressure and subsequently the pressure for use in the refrigerated space and throttling to the minimum pressure for the use in freezer. This is all will only require single compressor and condenser pressure.
My name is Muhammad Haris bin Abdul Majid, and today I want to explain about the application of second law of thermodynamics, which is specifically to refrigerators. So first, the important application of second law of thermodynamics is found in refrigerators and heat pumps also, which are based on the principle of reverse current cycle or reverse current theorem. The second law of thermodynamics says that heat can flow from high temperature reservoir to low temperature reservoir only. However, if you want to move the heat from low temperature to high temperature, then the external work has to be supplied. Okay, in our refrigerator, the freezer is maintained at low temperature by removing the heat from it. And throwing it to the atmosphere, which is at higher temperature. This does not happen automatically, then we have to supply electricity, which is used to run the compressor of the refrigerator. So the original Carnot cycle corresponds to the heat engines in which work is produced. In this cycle, heat is absorbed from the high temperature and released to the low temperature, and the work is produced. The same principle, and the next concept, the same principle is applied to the air conditioner and heat pump also. The air conditioner helps to keep the room cool when outside temperature is very high by removing heat from the room maintained at low temperature. The heat pump is used to keep the room hot when outside temperature is very low by absorbing the heat from atmosphere and supplying to the room. In the heat engine Carnot cycle, the large is the temperature difference between hot and low temperature. More is the work produced in cycle. In the reverse heat engine Carnot cycle, larger is the difference between low and high temperature. More is the work required in the cycle. And the last one is the engines used in the automotives and the compressor used in the refrigerators. Air conditioners and heat pumps seem to form the major applications of the second law of thermodynamics in our day-to-day lives. However, the fact is that these are just a few innumerable other applications of the second law of thermodynamics. Recently, an interesting program was released on BBC explaining the scope of the second law of thermodynamics.
So my name is Muhammad Faris, and I will give an overall summary for our report. In the conclusion, the refrigerator cycle consists of 4 basic stages. The first is throttle, where the decrease the pressure allow the coolant to expand into liquid or vapor mixture. Next is evaporation. Cross area is increased so that the coolant expand into a vapor, removing heat from the surrounding and cooling effect on the desired. And then compression. Refrigerant is compressed into a superheated vapor, which result in an increase in pressure and temperature. Then condensation. The condenser dump the excess heat generated from compression, allow the temperature to drop for the refrigerant to return back to the compressed liquid phase, where it is under high pressure but low in temperature. The four process will cycle continuously to cool the space until the desired temperature has been reached. The medium to carry the heat that we call the coolant usually use R22, although we could also use propane R290 and is very efficient refrigerant, but we do not use it because it is flammable. Then we use non-flammable refrigerant like R32 and R410. The cycle involves the change of state and energy and heat loss associated with the phase. With the change phase is the key to the process. Furthermore, there are more uses of refrigerator cycle in modern technology such as air conditioner, refrigerator, and heat pump. The process has revolutionized how the modern society operates. The modern grocery store would be impossible to store and sell fresh goods such as meat, frozen dairy, and our ice cream. Many large-scale production processor of goods and services would be unavailable without understanding this cycle. The influence of the refrigeration cycle has shaped the modern society and progress quietly.